Hey guys, here we are with 7.7. Again, just the basics, kind of. This one's a little bit more than the other two, because there isn't as much to cut out of this one. But it's still a front and a back, and I think you'll be okay with it. So it's talking about base E and the natural log today. The number E is a special number like pi. It's a math number. It's there, that goes on forever, doesn't repeat. So instead of writing it out every time, there's just one symbol for it, kind of like pi. Okay? It's often used in exponential equations, and that's why we're learning about it here. Y equals e to the x power. Just like our other exponential equations, its inverse is a log. But for a special number, e, we have a special log called natural log. And must be some sort of Latin thing or whatever that they're turned around. Instead of NL, it's LN, or you'll see it as lowercase ln. So if we were to see natural log of 4, that's like having log base e of 4. Or if you had x equals log base e of 4, or natural log of 4, then e to the x, 4 would be the power of e, or x would be the power of e that gives me 4. Alright, so I'm going to do these two, going back and forth between them, and I will show you the real easy shortcuts for going back and forth, and then we'll have you try those too. Okay, so going back and forth, to get rid of ln, you raise each side up as a power of e. So we have e to the x and e to the ln of 7. Okay. E to the ln of 7, e and ln cancel out, and the 7 just falls down. Okay, that's if you're trying to cancel out an ln. If you're trying to cancel out an e, you do natural log, or ln, of both sides. We use our log properties to bring the x down in front. Equals natural log of 7. Well, natural log and e cancel out. X equals ln of 7, and you see how we're back to where we started. Okay, let's give you a second here to try with those. Alright, same as before, bump each side up as a power of e, e to the x, and then e and ln cancel out, e to the x equals 12. Same thing we worked on over here. We do natural log of both sides. Okay, natural log properties, bring the x down in front. Natural log and e cancel out. X equals natural log of 12. Alright, let's use these to solve. Solving with e and natural log. Okay, so we have 3 times e to the 4x power minus 12 equals 15. Step 1, we're going to add 12. 3 times e to the 4x equals 27. Divide by 3. E to the 4x equals 9. Okay, now we're to the good part. Now we're to the good part with our e. Okay, you got to get rid of all those other layers, and now we're ready to natural log both sides. Natural log both sides. Alright, use our log properties to bring the 4x down in front. Natural log and e cancel out. So we have 4x equals natural log of 9. Divide by 4. And x equals natural log of 9 over 4. Notice that this 4 is on the bottom of everything. This isn't natural log of 9/4. It's natural log of 9. That answer divided by 4. So again, be careful here when you're typing stuff in. ln, so natural log, is right there by the number 4. Alright, and if you need to do e to the x, we have that as second ln. So second ln gets me the e to the power Okay, I don't need that right now, though. I just need natural log of 9. Close that parenthesis, and then divide by 4. So we got 0.5493. Okay. This one over here, we have an ln. Our x is trapped inside of it, so we will need to use e to get it out. But there's a really tricky part to it right away. Notice that we have a natural log and an exponent. So the very first step here is to bring this down in front. It's a tricky step, often overlooked, and people forget about it. All right, so we have 4 times natural log x minus 8 equals 4. Divide by 4 to cancel those out. And this is going to be a 1 over there now. Natural log x minus 8 equals 1. Now we're ready to get rid of the e, or to get rid of the natural log by bumping these up as powers of e. Okay? Those would cancel. X minus 8 falls down. E to the first. Alright, we're going to add 8 to both sides. E to the first power plus a big 8 at the end. Okay, so second natural log. Oh my gosh. I'm not ignoring my kid if you can hear Ari in the background. She's playing with Tara. She's just having a little too much fun, I guess. Plus 8. $10.7183. That's going to round up to a 7183. All right. So there's that one. I did set some up for inequalities, but I don't think we're doing inequalities with the shortened schedule for our online school. So we're going to ignore that one because that's the same one we did, just an inequality sign. We can try this one though. Why don't you hit pause and try that one? It should be very similar to the one we just did. Alright, so first thing, this is similar to the last one. It's a natural log of something with an exponent. Real sneaky just to bring that down right away. So we're going to divide by 3. Okay. Next, we're going to bump everything up as a power of e. So we have 2x minus 3 equals e squared. Add the 3. And then divide by 2. We're going to divide that whole side by 2. Alright, so super tricky here typing this in. It's an often missed problem. Kids will just type it right in. Okay, you got to do the whole top and then divide by 2. So we can do big parentheses, second function e squared plus 3 closing parentheses, now divide by 2. Okay, or you could have done e squared plus 3, enter, divide by 2, enter. We got 5.1945. 5.1945. All right. And another application of E comes a lot in finance world with continuous interest. Okay, much better than any of the compounded monthly or quarterly or whatever we had before. The best option is continuous. Okay, so let's say I put $2,000 in a bank account at Aria's birth, and it's in an account paying 4%, compounded continuously. Yay for us. How much would it be worth in 10 years? No deposits, no withdrawals. You're going to see that in the homework. That just means you didn't put any extra money in throughout those 10 years. You didn't take any extra money out of it during those 10 years. It makes it a lot easier to calculate. Otherwise, you have to keep breaking it up into little pieces and stuff. And it gets a little more complicated, a lot more detailed. All right, so P, still the same as our other equation. P is your starting amount, your principal. We got the Ellen show going on in the background. I'm sure you guys can hear a little bit of that too. That's just the craziness that is online school from home. All right, again, R, it's your rate as a decimal, 0.04 times the time in years, T, so times 10. So you could type it in. You could probably just type it in right now, just like that. Or I'm going to simplify this. 0.04 times 10 is just going to be to the 0.4. So we'll show you how to type it just straight in. 2,000 times E. All right, and then we can just type everything in up there. If you have an older calculator that's going to give you just the caret key, you're going to want to put parentheses around that. 0.04 times 10. All right, $2,983.65. Okay, so like, wow, big deal. It's 3,000. That's over 10 years. That's not a very big deal. All right, true, but the bigger amount you would have put in there, so that's almost 50% increase. It's almost like, so half of 2,000 would have been $1,000, $3,000. So if you would have put in 10,000, you'd have been at almost 15,000 after 10 years. You would have gained $5,000. All right. How long until that same thing is worth $4,000, aka it doubles? So you know what you want your final amount to be. I know I want my final amount to be 4,000. I know I started with 2,000. It's still times E. My percent is still 0.04. I don't know what my time T is up there, though. I don't know what my time T is up top. So we divide by 2,000. 2 equals, see, so it doesn't matter how much you would have started with. Let's say for like it doubles. If I said, oh, I started with 5,000, I want it to double to 10,000. The first step you do is you're going to divide by 5,000, you're going to end up with a 2. So you're going to find that it doesn't matter what the amounts were, it's just the time for you to double your money. So this would have been the same amount of time to double whatever money you started with, whether it's $2,000, $10,000, because your first step is to divide by this, and either way, you're going to have 2 there. E to the 0.04 T. Okay? Well, my variable's up top. There's nothing left over here. How do I get it down from an E? Natural log both sides. So now we have ln of 2 equals natural log and E cancel out. We have 0.04 T. Divide by 0.04, and when you divide by a very small decimal, you actually make it bigger. All right, if I divide by 2, I would cut something in half. If I divide by 1, it stays the same. All right, if I divide by a decimal smaller than 1, it's going to actually get bigger. So we have natural log of 2. I'm just going to hit enter now, see what it is. Divide by 0.04. Okay, so to double, it's going to take about 17 years. 17 point, well, I mean, think about what we're talking about, years. Like 4 or 5 decimals isn't going to make sense here. So let's call it 17.33 years. All right, so there is our quick mini lesson for 7.7. That will cover the chapter there. That'll be the end of the chapter. We'll have another quiz. There should be a worksheet for this right next to where you found this video. And note sheet. There should be a worksheet for 7.7. And we'll have a practice quiz, review day, and then the quiz, and probably have a review day for the test, and then the test. So, all right, guys, thanks a lot. We'll see you in virtual class.